Hello guys, welcome once more to our class online, and my name is Mr. Jamb. And in this class, we shall be looking at Jamb Physics 2019 question number 16 to number 20. Okay, if you are ready, I'm ready too. So don't forget that if you really enjoyed this video, please click on the like button so that you can get more content from us from time to time. Let's check out number 16. Question number 16 said, which of the following phenomenon explain the formation of a mirage? Now, we have reflection, refraction, and diffraction. Now, you have been taught about mirage, right? Now, mirage is that optical illusion. That's something that is not real. Optical means it from the eye. So, mirage is when you are traveling on the road, you look to the front of the road and you see water. Like if you are traveling, maybe some of us travel to the village. If you are traveling to the village at the end of the year and you are in your vehicle and then you look far down the road, you will see something that looks like water. That is mirage. Actually, when you travel to that point, you will see that there is no water there. That's what is called a mirage. A mirage is something that looks real, but it's not there. It's not really there. So it's an optical illusion. Illusion means it is a deception of your eyes. It's from your eyes. That water you see is a deception of the eye. So this question said, what is the reason for mirage? Is it reflection, refraction, or diffraction? Now let's look closer at it now. Let's explain mirage. An illusion sometimes seen as sea in the desert or over earth pavement that looks like a pool of water on a mirror in which distant objects are seen inverted. Now, you can see my vehicle in the picture there. It's looking at a different vehicle, but it's seeing the guy in the car is seeing water coming. There's water between him and the coming vehicle. So that water is not really there. It's just in the rain. So an object in which objects are seen inverted. Now a mirage is a naturally occurring optical phenomenon in which light will bend, okay, via refraction to produce a displaced image, okay, of distant object or the sky. The word comes to English via the French mer from the Latin mirare, meaning to look at or to wonder at. Now, let's explain this now. In physics, mirage is caused by something, and that thing is two. One is refraction, and refraction is the bending of waves. Now, this is how it happens. I'll explain it now. It happens in a hot day, okay, that the sun ray hits the ground, and then the ground gets hot and produce heat. That's heat. Now, when you are traveling on the road, you'll be seeing what we are seeing as water is not really water. It's just the hot road. It is the heat of the ground. Then the moving it moves like water. So it is the movement of the heat caused by refraction. And you may be wondering why am I saying refraction? Refraction is the bending of wave. You know, when the wave, light wave coming from the sun, gets to the earth, to the heated road, the earth wave on the road bends the ray of the sun. So what I said is that the road is heated, right? Now, when the road is heated, it produces waves, right? Now, those waves are moving like water, but when the ray of the sun gets to the earth medium, you know, refraction is the bending of wave when it's moved from a medium into another medium. So the first medium is the atmosphere. The second medium is the earth road. So when the when the ray of the sun coming from the atmosphere get to the earth road, it changes from the medium of the atmosphere to the medium of the earth road, and then it causes the ray to bend. So that bend is called refraction, and that's why refraction is the reason for mirage. So when the sun ray gets to that point and bends, it will form something that looks like water. It will dance like water, and then when you're traveling and you see that bending, you will say, oh, that's water. That's not really water. That's the sun ray bending due to the heat of the road. Okay, that's the meaning of refraction, and that's the scientific explanation for refraction. So, for mirage. So, the mirage phenomenon is caused by refraction, and it's also caused by total internal reflection. That one has to do with your eye. So, and that one has to do with light coming from your eyes, going to that point and bouncing back. So you will see the coming object. So that means in this picture that we have here, the light coming from the eye of the driver get to the mirage, that's to the water, and bounce back. That bouncing back is called reflection. So it is caused by both refraction that's coming from the sun and coming to the earth medium and bending. The bending of the sun ray, number one, refraction, and number two, reflection from the eyes of the driver. Okay, that is looking at the mirage. So when you are driving and you saw the mirage, the reflection is happening from your eye to the water point and to the coming vehicle, like in the case I have on my slide. So it is caused by both reflection and refraction, but not by diffraction. Okay, because diffraction is spreading out, and there is no spreading out of wave here. So diffraction is wrong. So the answer is simply option 1 and 2. That makes option C the correct answer to that question number 16. Let's check out number 17 now. It says an object is placed 5.6 times 10 to the minus 4 meter in front of a converging length, which is a convex length, of course. Now, of focus length 1 times 10 to the minus, that will be minus something. Okay, but actually that will be more than the first one, right? Okay, meter. The image form is what? Now, this is asking a question about converging length or convex length. Converging length or convex length. Okay, so this one says that the object, now actually the position of the object is in front of the lens. Okay, and the position of the object is closer to the lens than the focal length. So that means it is between the lens, okay, and the focal length. Okay, now in your mirror diagram, if you have, in your lens diagram, you have a converging lens between the focal length and the lens, the focal length and the lens. Okay, now what happens through the image? If you have an object between the focal length and the lens, what will happen to the image? Now let me remind you of that. Now what we were taught is that whenever the object is between the focal length and the lens, the image will be, number one, it will become magnified, it will become bigger, okay, and number two, it will become virtual. That means it can be formed on a photographic plate or film. And number three, it will become erect and it will stand upright. And number four, it will form on the same side of the lens. Okay, it will form on the same side of the lens. That means it will form on the same side of the lens. That means it will form above on the same side of the lens. So these are the characteristics of the image when it is between the lens and the focal length. Okay, you get that. Now we have to just sit down with this and memorize and study the different position of the image. You know, this under wave, that's optical wave, and this under mirror. Okay, actually under mirror and lens, we have one for mirror and we have one for lens. Okay, so this is under that topic now, and this is talking about convex lens. Okay, so we have to study different positions of images with different positions of objects, and this, in this case, because the object is between the lens, okay, and the focal length, it will have these characteristics for its image. The image will, one, be magnified, two, it will be virtual and erect, and three, it will form on the same side of the lens, and that gives me my answer. Okay, so let's check out which one is correct. Making that means option D is correct. Let's see, it is virtual, it is erect, and it is magnified. So the answer is option D. Now, what you have to learn about to know this question is to learn the different positions of images with different positions of objects. Once you know that, then you'll be able to tackle questions like this. Okay, let's go to number 18 now. Number 18 says a bar of initial length LO is heated through a temperature change T to a new length L. The linear expansivity of all the bars. Now we have this. Now this question is simply asking about linear expansivity. Does that ring a bell? Now we have been talking about linear expansivity, right? Now linear expansivity is just L2, okay, over minus L1 over L1 times theta 2 minus theta 1. So that's change in length over length times change in temperature. So even in fact, if you know the definition, you can define linear expansivity as it is change in length per unit change in temperature. That's it. Change in length. That is even the definition of linear expansivity in case we are asked to define it. It is change in length. It's just from the formula. change in length per unit length per unit change in temperature. Once I know the formula, I will naturally know the definition. Let's check about that. Let's check that out. So linear velocity is L2 minus L1. That's the second length over the first length over the first length. Sorry, minus the first length over the first length times change in temperature. That's temperature 2 minus temperature 1. So now in this case, we have been given that the first length, initial length is LO. So I will just substitute, instead of L1, I will put LO. Okay, it's either through a temperature change of T. My temperature is T. So I put T in that place. So give me T. Then to a new length, that new length is length 2. So where I have length 2, I will change to L. Okay, so that will give me linear velocity is L minus L0 over L naught times change in temperature. I'll come again. L minus L naught over L naught times change in temperature. And that is my answer. And that is the formula for linear expansibility modified. Okay. Now let's see that now. Let's see the option that's right. That's option A, right? Option A is L minus L naught. Okay. Over L. Oh my. Okay. Over L. That's supposed to be L naught, not L. That's supposed to be L. So L minus L naught over L times change in temperature. Let's check that out again. So that's L minus L naught over L naught times change in temperature. And the one that suits it most, okay, it's like there's so much competition, there's no too much of the one that suits most. But the one that looks like it more will have been option B, not option A. That's L minus L naught. Take note, L minus L naught over L naught times change in temperature, making option B the one that's closest to the answer. Is L minus L naught over L naught times change in temperature. That's it with number 18. And let's get to number 19. Number 19 said a moving coil galvanometer of 300 ohms resistance gives a full-scale deflection of 1 milliampere. Full stop. Then the resistance R of the shunt that is required to convert the galvanometer into a 3 ampere ammeter is what? Now this one is simply asking for shunt resistance. Now when there's something called shunt and multiplier, and the principle of shunt and multiplier is what we have in our transformer. Transformers can multiply current. Transformers multiply current and can also shunt voltage. So it is an interplay between those two factors. So now we have here current and we have resistance. Now, whenever you have a question on shunt, the formula to use is 1, and I will show you that formula. Keep this formula for any question on shunt. This formula can tackle any question on shunt. Okay, so let's look at that now. This is the formula. It says resistance of shunt or shunt resistance equals resistance of galvanometer times current of galvanometer over current minus current of galvanometer. Once you know this formula, you can answer any question that comes on shunt. Let me come again. Shunt resistance is equal to resistance of galvanometer times current of galvanometer over current minus current of galvanometer. So that is the almighty formula for anything shunt. Okay, good. So let's put it in. So I have I've defined everything there. So what I'm looking for is my shunt resistance, which is equals to Ig, I minus Ig. Now my resistance of galvanometer from the question is 300 ohms. Can you see that? Good. Then times the current of galvanometer, which is given to me as 1. Okay, that's 1. That's 1. So that's 1 times 10 raised to power minus 3. That's just okay. Let me see something. Let's check it out. That's supposed to be 1 milliampere. That's not supposed to be just 1 ampere. That's 1 milliampere. Okay, so that's supposed to be 1 milliampere. Now, okay, so anything milli means 10 raised to power minus 3. So the current of galvanometer in the question is 1 milliampere. And milli means 10 raised to power minus 3. Okay, so it's good to take into question. Watch out the question very well, because you might be working with the wrong parameter and that will give you a problem. So this is a lesson. always check the question more than once, okay, so that to ascertain that you do it well. So we have milliampere. So that's 1 times 10 to the power minus 3 over 3. And that 3 is the current. That's 3 ampere minus 1 times 10 to the power minus 3, which is the galvanometer current. That's 1 milliampere. So that will give me 300 times 1 times 10 to the power minus 3. In this case, you have to break it down. Okay, so 0.001 over 3 minus 0.001. Okay, so I have 300 times 0.0. That will give me 0.3 over 3 minus 0.001. That will give me 2.99. If you divide that, you'll be getting 0.1 ohms, and that is the shunt resistance, 0.1 ohm, and that makes option B the correct answer. Now, don't forget, in this option, all you need to know, which is most important, is the formula of shunt, which is RS equals RG IG over I minus IG. Once you know that, you can solve any question on shunt. So let's go to the last question for this video section. So we have which of the following arrangement of the component of electromagnetic spectrum is in ascending order of wavelength. Now, when you get the word electromagnetic, you should remember reverse G. Now, reverse G is just the formula that helps us to remember all those guys. You know, there are so many guys under the electromagnetic wave, and those guys are just reverse G. And now, let me just show them to you. We have reverse G. There are just 6 of them. That's the 6 major ones anyway. And reverse G means R. R means radio wave, and I means infrared. B means visible light. U means ultraviolet, and X means X-ray, and G means gamma ray. So these are the 6 electromagnetic waves. Now, if you know them, the next thing that you must know is increasing frequency. That means frequency increase towards G. That means the guy with the highest frequency is gamma, and the guy with the highest wavelength is radio wave. So radio wave are longer, while gamma ray are the shortest, but they have the highest frequency. So they said in the order of ascending wavelength, that means from the one with the lowest to the highest wavelength. So I picked them out. So in the order of ascending wavelength, the one with the lowest wavelength is gamma ray. Okay. When it comes to wavelength, the one with the lowest wavelength length is gamma. Why that gamma is the one with the highest frequency, but is the one with the lowest wavelength. Okay. So now, in order of ascending, means from the lowest to the highest. So the lowest is gamma, followed by, according to the option I have, if you write this out, then you can pick out the ones that you need. Gamma, followed by X-ray, followed by ultraviolet, and followed by infrared. Infrared has the longest wavelength in the list of options we have, making option C the correct answer. That brings us to the end of this section. Now, don't forget, if you really enjoyed this video, to like the video so that we can get to reach you from time to time and share more fun-filled videos that will help you in your journey of understanding physics. Until we see you next time, take care of yourself. Bye for now.